In this video, we are going to look at examples of relative velocity with regard to one-dimensional motion, that is, motion of bodies along a straight line. So say for example, we have two cars, car A and car B. Car A is moving in this direction with a velocity VA, whose magnitude is 30 kilometers per hour. And car B has velocity VB, having magnitude 40 kilometers per hour. And as you can see, car B is moving in a direction opposite to that of car A. So VA and VB, they have opposite directions. So what is the relative velocity of car A with respect to car B? The relative velocity of A with respect to B is given by VAB. This can also be read as velocity of A as seen by B, which means B is the observer over here. So VAB is given by velocity of A minus velocity of B. This is the formula for relative velocity. This whole scenario is like you are inside car B, moving with a velocity of 40 kilometers per hour, and you're looking at car A coming towards you. So what does it seem like to you from inside car B? That's the case we are dealing with. So now, substituting the values of VA and VB in this formula, we get the relative velocity of A with respect to B is given by 30 kilometers per hour minus 40 kilometers per hour. Now, where do we get this minus sign from? That's the thing we need to understand. Since this is a vector equation, in order to incorporate the direction of velocity, what we've done is we've taken the direction of movement of car A to be positive, which means if this is positive, this direction is positive, then the direction of B, that is the opposite direction, should be taken to be negative. It's like this is the positive x-axis and this therefore has to be the negative x-axis. So VA is taken to be positive 30 kilometers per hour. So the moment we write positive 30 kilometers per hour, remember we are incorporating both the magnitude and plus sign gives us the direction. So we are incorporating both the magnitude and direction of velocity. So this is the minus sign. And since VB is moving in the opposite direction, so therefore the velocity of body B or car B is taken to be negative, minus 40 kilometers per hour. So we've incorporated both the magnitude and direction part of the velocity in this equation. So finally, therefore, the relative velocity of A with respect to B comes out to be 70 kilometers per hour. Since VAB comes out to be positive, it means that the velocity of A as seen by B has the same direction as VA. So to say, when you inside car B are looking at car A coming towards you, it seems to you that this car A goes zoom past your vehicle with a velocity of 70 kilometers per hour. And this is also what we actually experience in our daily life. You must have experienced this while traveling in a train. Of course, not a famous toy train I'm talking about. I'm talking about the long trains that you have in the planes. So say for example, you are moving in this green train towards the left hand side, and you have another train coming on a parallel track. Okay, it's this brown pen, but it's moving in the opposite direction. So when you look at the brown train from your green train, it seems to you that this train goes past your green train with a very fast velocity, like that. So remember, this is the case when you are the observer. You're observing from, of course, car B. What if you have a friend inside car A and now your friend is the observer? So to say, your friend is looking at you or looking at car B coming towards himself or herself. So to say, what is the velocity of B as seen by A? The velocity of B as seen by A is given by velocity of B minus velocity of the observer, that is velocity of A. A is the observer now. So this is equal to, since we have taken the velocity of B to be negative, so VB is minus 40 kilometers per hour, this minus sign, and VA, we've taken this to be positive, so this is 30 kilometers per hour. So we get to see the relative velocity of B with respect to A is equal to minus 70 kilometers per hour. So this means when your friend from inside car A looks at you, it seems to her or it seems to him that you or your car is coming towards her. That is, your car is coming in this direction with the fast velocity of 70 kilometers per hour. Now let us look at this other example where we have two cars A and B moving in the same direction. Both of these two cars are moving towards our left. A is traveling with a velocity equal to 30 kilometers per hour. B is traveling with a velocity of 50 kilometers per hour. Now try to visualize this. The velocity of B is faster than that of A. So at some point of time, B is going to overtake A. So if the observer is inside car B, you are inside car B, what does it look like to the person inside car B when he or she looks at car A? So to say, the relative velocity of A with respect to B is equal to VA minus VB according to the formula. Now since we've taken this direction to be negative, VA is minus 30 kilometers per hour. This is the minus sign. VB is also negative. So therefore minus 50 kilometers per hour. So minus into minus becomes positive, and thereby the velocity of A as seen by B comes out to be 20 kilometers per hour. And you can see this is positive. So if you are inside car B, what does it look like to you? When your car B overtakes car A and you look at car A, so it seems to you that car A is moving in the backward direction. Car A, so to say, is moving in this direction. Therefore, a positive sign with a speed of 20 kilometers per hour. Likewise, when your friend inside car A is looking at you now, okay, so to say, your friend is the observer now. So what does it seem like to your friend? That is given by the relative velocity of B with respect to A, which is equal to VB minus VA. Now VB, as you can see, is negative. So VB is minus 50 kilometers per hour. This is the minus sign. Also VA is negative. So therefore we have minus 30 kilometers per hour. Therefore, the velocity of B as seen by A comes out to be minus 20 kilometers per hour. So to say, when your friend from inside car A looks at you, your car is going to overtake, alright, and your friend is still observing. So your car, after overtaking this car A, your car goes forward in this direction. That is the negative direction, okay, and so negative sign. And it seems to your friend inside car A that your car B is moving with a velocity of 20 kilometers per hour.